Hi everyone, welcome to my channel. In this video I'm going to be explaining the meaning of function, the meaning of domain, the meaning of range, and the meaning of codomain. I'm going to give example each to every one of them. Now we have here that a function is a rule or relationship where every input gives exactly one output. Now we have here x, we have here y. This x here is known as what? The domain, while the y here is known as what? The codomain. Now this x and y is the same thing. This is when we have the bracket is an ordered pair. The same thing we have here. One is the domain, two is the codomain, and this is the ordered pair. Now they say the function is a rule or relationship where every input gives exactly one output. I said earlier that x here is a domain. X can also be called the input. I said here that y is the domain. Y can also be called the output. So in a situation whereby an input is paired with only one output, you can see here that the input here is paired with only one output. For the input here 5 is paired with only one output. That is the reason why they said a function is a rule or relationship where every input gives exactly one output. Now you can see that this is an ordered pair, as I explained earlier. Now we move forward to domain. Domain is a set of all values that can be substituted for x such that the function can be defined. Now, for example, here we have fx is equals to x plus 2. If we substitute 1 into the place of x, we have here that 1 plus 2. We substitute 1 into where we have x. 1 plus 2 is 3. In the situation where we have 5 as x, this is going to be 5 plus 2, which is equals to 7. Now, we have here minus 2 and we have here 0. Now, these values that are being used to start up the calculation is called the domain. Now we have here that any number can be put so that the domain is real numbers. This is a sign for what we call real numbers. All real numbers. Another example. The reason why we say that the domain is all real numbers is that the negative sign can be put here, a positive sign, any number, even if it is 0. So nothing is excluded. Every number, both the negative number, the rational number, any type of number can be put here. Any number. Now we have here another example. Fx is equals to 1 over x. The domain is said that all real numbers excluding 0. This sign means excluding 0. Now, why do we say that all real numbers excluding 0? That the domain is that all real numbers exclude 0. Now, you can see here that if x is found to be 0, we are going to have 1 divided by 0, which is what? Undefined. Which is undefined. So now all numbers can be inserted into this x to make it defined, but only 0. We can see here in the number line that the number between the negative numbers and the positive numbers is 0. And here we have the minus infinity. Here we have the plus infinity. Because if you keep moving from minus 1 and you keep going, we go to infinity, then the plus, we go to infinity. Now if you notice, this is a circular bracket. We have two types of brackets when finding the domain or range. When you see a type of bracket that is in this form, this means included. When you see a type of bracket that is in this form, this means excluded. Now I want to explain why we are now using these two brackets. These brackets to determine the range of this function. Now we said all real numbers except 0. Now this is 0. Now since 0 is not included, since 0 is not included but excluded, we now say minus infinity, comma 0, union 0, comma infinity. Now we usually know that if we want to write numbers, we start from the small number 1, 2, 3, and 4. That is why here I started from the minus infinity and then comma, and then here is 0. Then at this point I started with 0, comma infinity. And at this point we know that infinity is greater than 0. Infinity is greater than 0. But at this point minus infinity is less than 0. Why is minus infinity less than 0? You know that if we borrow 1 million naira, someone that has exactly 1,000 is richer than us. Why? Because he actually owns the 1,000 naira. which makes it plus 1,000, while the 1 million naira is minus 1 million naira. So plus is usually greater than minus. So that is the reason why we have this bracket. And the reason why this minus infinity and plus infinity is within these brackets, not this type of bracket, is that minus infinity and infinity, they are not real numbers, because this particular sign cannot be reached. That is why it's within this bracket instead of having this included brackets. Now, with more solvings, we are going to be able to find the domain of a function using the interval form and using this form. Now we move further to the range. We say that the range is a set of all possible output values of the function. For example, fx is equals to x plus 2. We have here f1, f2, f3. We have the values here. We said earlier that the values we use to start the calculation is known as the domain. Or the input. We have here 1, 2, 3 as a domain or input, and then now we have the values 3, 4, and 5. These 3, 4, and 5 are the range, while 1, 2, 3 are the domain. I said range is a set of all possible output values of the function. Now, those output values of the function that are being produced as a result of imputing this 1, 2, 3 as the domain in place of x is called the range. The values we get when imputing some values of x, some values into this x, having 3, 4, and 5. These are the values, so they are the range. We'll be looking at the codomain. From the definition, we can see that the codomain is a set of values where outputs are expected to come from. For example, we have f as a function from this domain to this codomain, which is the same thing as f as a function from A to B. Now, being defined by fx is equals to 2x. Now, if we input these values 1, 2, 3, which is the domain, into this value 2x, inputting 1 here, we have 2, inputting 2 here, we have 4, inputting 3 here, we have 6. Now, here is written that the domain is 1, 2, 3. We all know what the domain is, set of values that are used to start the calculation of a function. And then we have the codomain. The codomain here are 2, 4, 6, 8. Since these values tends to this value, you can see that these values are the set of values where the output are expected to come from. Now, the outputs in this case are 2, 4, and 6. 2, 4, and 6, which is a range. We know the definition of a range, that a range are those set of values that are being produced. For example, when imputing the domain into a function, the value that is being gotten is the range. So now you can see here that due to the domain that was given, we have 2, 4, and 6. 2, 4, 6, and 8. 2, 4, 6, and 8 is a codomain, and then 2, 4, and 6 is the range. You can now see, but letter 8 is not part of the range here. You can see I wrote that. Notice that 8 is in the codomain but not in the range. So I would like to explain the fact that you can have a function where the codomain is exactly the same with the range. You can have a function where the codomain is not exactly. Now you can see here, at it being we had 1, 2, 3, 2, 4, and 6. 8, if 8 was excluded, if 8 was not included in this codomain, you would realize that 2, 4, and 6, which is the output, will be exactly the same with the codomain. But a situation where we have 8 here, but the last domain or input that was being exerted into the function fx is equals to 2x gives us 6. So 8 is not included. 8 is in the codomain but not in the range. Thank you.